Welcome back. This is an Aleks training video on using specific heat capacity to find temperature change. If you remember, the heat capacity is the amount of heat it takes to put 1 gram of a substance up 1 gram Celsius or 1 degree Celsius. So that's based in a couple different things. You've got the amount of heat it takes, but you also have the amount of mass. A certain amount of heat would raise temperature to a certain amount of mass, so you could find mass. You could also find the change in temperature. So if you knew how much mass there was, and you knew how much heat, and you knew what substance it was, so you knew its specific heat, you could find out what its final temperature or its initial temperature is, and that's what this is. So they're asking you to find a final temperature of some water after you put a chemical reaction inside a water bath. So you've got originally, let's see, so you've got a chemical reaction that's happening, like say in some kind of a flask, and it's heating the water. So that heat that comes out of the chemical reaction into the water, if you know how much water it is, and you know how much the temperature went up, then you know how much heat was there, and you know the specific heat of water. You can find out the final temperature. Right, so the initial temperature is going to be T sub I is going to be 21.2 degrees Celsius. The change in temperature is the final temperature minus the initial temperature. So we're going to solve for the final temperature. So we're going to use this. We've got the specific heat of water as 4.18 joules per kilogram Kelvin, or per gram Kelvin. We're going to have the heat that flows out of it, 109 kilojoules. I'm going to put it in joules since this number is in joules. So that's 109. Okay. I have 2.2 kilograms of water. Okay, but I have grams here, so I want to put that in grams. So kilogram is 1,000, so 3 places. Okay. And then I'm going to have the change in temperature. So I'm going to solve for change of temperature. So I'm going to move it up and move the 4.18 down. Okay, so I have change of temperature equals 109,000 divided by 2200 times 4.18. This is final temperature minus initial temperature. Okay, my initial temperature is 21.2 degrees. So to solve for this, I'm going to have to add this to the other side. Okay, and that should do it. Okay, final temperature is this temperature plus whatever this raise in temperature is. All right, so I've got 109,000 divided by 2200 equals divided by 4.18 equals, okay, so it's going to be this temperature plus this much more. So when I add 21.2, I'm going to get 33.05. So let's look for significant digits. I've got 3, I've got 3, I've got 3, I've got 3. So I want this to be 33.1 degrees Celsius. Okay, thank you.